You can proceed, David.
Okay, thanks, Borja. Good morning and welcome, everyone. Thanks for joining us in one more English webinar organized by the EGA Group. Actually, this is the first of 2023. Today, we'll be talking about electrical safety and the use of 1000 volts insulated tools in industrial MRO, industrial maintenance. This is something we may commonly associate mostly with the power sector, with energy sector, but in fact, electrical risks are involved in almost every single industry. Electrical maintenance is a must, and thus I believe there's quite a wide scope for this range for today's webinar in particular. Even the electrical vehicle industry as well is another area that we are quite focused in the EGA Group. So we'll talk about all of this more in detail in the next, let's say, 40 minutes, 45 more or less. This is a webinar we organize once again for our partners and end users alike from regions like Asia, the Middle East, Africa, or Europe. And we can probably say that once again, there was a lot of interest, a lot of registrations and participants. I believe today we'll have about 40 people joining from 40 different countries. So once again, thank you for joining us. Let me introduce myself at this point for those that I haven't had the pleasure to meet before. My name is David Esteves. I'm the International Sales Director of EGA Master. And with me today, as always, we have my colleague Borja Marugan from the marketing department, which, as always, is a great support in all our marketing events and responsible for the very proactive and regular marketing communications we are sharing almost on daily basis. And on the screen, you can see as well the email address that you may use later on to contact us directly. Share with us your questions or any comments that you may have. The plan, of course, as usually is to save a few minutes at the end of the presentation to answer at least some of these questions, but I know that often we are already running out of time and we may only find the time maybe for a couple. So it's always wise and easier if we have them in the box and be able to respond later on by email. So please use the section, I believe, on the top right corner of your screen on the audience side, and we'll do the best to review it during the event itself. Before I forget, let me invite you right away to follow our profile on LinkedIn, so you can also be constantly updated about EGA Master, new products, new releases, technical info, expertise in subjects like the one we are addressing today, info on accidents and how to avoid them, etc. So I do believe we share very interesting content on a regular basis and that it may be of interest to you as well. So moving on, let me brief you on what's the program for today's webinar. Before getting into the main subject, the idea is to start with a very short company introduction based on our value proposition and proven experience. For those of you that are not yet familiar with EGA Master, we'll make it short, I promise, so don't worry about it. But I believe it's always fundamental for one to know who's addressing you in a particular subject, particularly when we are talking about safety-related matters. So after this quick overview, we'll then focus on the main subject for today, starting with the context related with insulated tools, from an historic overview to what they are, main areas of use, etc. We'll continue with a brief discussion on how to use them, which aspects to have in consideration. We'll address then the regulatory field and certifications. That's something critical when it comes to safety tools and the reason why standards do exist, obviously. And we'll finish by describing some of the most common insulated tools before ending with the already mentioned Q&A part of today's session. So moving on, let's start with a brief introduction of our company, not more than 10 minutes for sure. So EGA Master is part of a family-owned group from the north of Spain called the EGA Group, located in the Basque Country, the industrial heartland of the country of Spain. And in the group, besides EGA Master as a premium tool manufacturer, we also have our sister company, EGA Solutions, an engineering company developing technologies and offering solutions for the 4.0 industry, including, for instance, inventory control systems and solutions, geolocation devices, smart stations, torque control and management solutions, etc. Oh, sorry. Since the 70s, and we are actually celebrating our 50-year anniversary this year, we have a very well-defined purpose to develop and manufacture high-end innovative solutions aiming at maximizing safety and efficiency of the most demanding industrial operations. Those are the two areas, or let's say key concepts we are focused on daily basis. Since helping industrial end users and giving our contribution to building a safer and a more sustainable world is a fundamental part of who we are, of our culture as a company. And to achieve it, we not only offer the products we manufacture, but also different kinds of solutions and value-adding services, including the special and tailor-made engineering solutions. As a company, we do have a global presence with partners in over 150 countries, exporting roughly 90% of our annual production, including over 50% to emerging markets. And we also have different subsidiaries and sales offices across regions, allowing us to be closer to the field, be closer to where our solutions are actually needed and used. Some figures that I believe will be interesting to share with you and that show how we managed to maintain our well-known and unmatchable service levels, even during very challenging times we all experienced with supply chain disruption, issues with raw materials during the last few years, etc. And this is a great example of our core values and customer orientation, our focus in being a solution provider for those that selected Egamaster for their MRO operations or assembly or operations, and at a quality level that falls in line with it, in line with the needs of demanding industrial companies that selected as their supplier of premium certified hand tools. As a company, as a manufacturer, we are committed to excellence at all levels, by far the most awarded in our industry, in our field. We are not investing much of your time today on it, but you can see on your screen some of the most important recognitions and awards we received over the years, and much more you can find on our website. We are, again, as a company, fully certified by the most demanding third parties, from corporate to quality certificates, the 4 ISOs, for instances, to safety certificates related with some of the key product families, including, obviously, the 1000 volts range that we are focused on today. Something to quickly share as well, because as you can imagine, makes us all quite proud of is the fact that we were selected some years ago to be part of the group of leading brands of Spain. So this is a group of about 100 companies, about 100 brands in over 45,000 in the country, that were considered to be the ones that better represent Spain in all the corners of the planet, to be the flagship of the country. And we are actually the industrial company from Spain exporting to the largest number of countries, over 150, as I mentioned earlier. Let me guide you very briefly to what we consider our unique value proposition in a very summarized way, what makes us different from all others in our industry, and how does that benefit you as a partner or as a user of our tools. So first of all, everything we do was engineered, designed and manufactured, having in mind the most demanding and heavy-duty industrial applications in mind, everything premium and fully certified by the most prestigious third parties. And in that sense, our range is by far the largest in the industry, allowing to manage the complexity of procurement processes, improve its efficiency through a one-stop source that covers all your needs, from standard to niche products, in over 23,000 part numbers that are part of our master catalog, our V23 catalog, recently released. As a company, we are also proud to be very agile and flexible, to be focused more on the solution side of the business than the product, particularly solutions that help improving tool control and traceability, that avoids all the costly and in many cases risky tool losses. So that's also a substantial part of what we do, a very important pillar of our offering. And we include as part of these solutions, of course, the ability to develop and customize foam trays and storage solutions for proper organization and of the workshop following the 5S policy. But we can also engrave any single product with our company, with your company logo. Additional tracking details that helps you in terms of traceability without any MOQ, and whatever helps you to better control your assets. And last but not least, again, the high-end service level that is a fundamental element of who we are and what makes us different when compared with other companies. But how can we prove that what I just said it's actually true? I can show some references. So starting with some case studies, mostly new infrastructure projects is a very important channel for us. And I can name, for instance, the Daqingxia hydropower plant in China, the third largest in the country, or the Baraka nuclear power plant in Abu Dhabi, managed by the Nawe Energy Company. The Songo Songo Gas and Power Development Plant in Tanzania, one of the largest power projects in the continent over the last few years. But for instance, I can highlight the over 2,000 customized sets developed last year alone for Saudi Electricity, ensuring that they could maintain the power network all over the country with the insulated tools we manufacture. The project also in Saudi Arabia to ensure power supply to the Riyadh Metro by a major player in the business, the ABB, or the mobile workshop container solutions developed for maintenance of the GE turbines on TAQA's Takoradi combined cycle power plant in Ghana. I want to show you a few pictures of these and other customized and tailor-made projects as well, showing once again our ability to listen and understand the customer needs. That's again something crucial for our business. The focus on the specific and unique solutions that users need. Like for instance, these sets we developed for ARO drilling anti-drop sets, including anti-drop insulated tools, ARO drilling from Saudi Arabia. The customized tool sets for the nuclear power plant of Nawe in Abu Dhabi. Solutions offer both for workshop and field interventions of Global Atomic, a Canadian company managing uranium mines in the Republic of Niger, or to the Railway Company of France, which uses the 1,000 volts insulated torque wrenches and these specific sets we developed to them for their MRO activities that you can see on the screen. So everything here was 100% customized as per the specific needs of these users, including storage and workshop solutions, bicolor foam trays for better organization, and the already mentioned laser engravement for traceability. Among dozens of testimonials that we received over the years on the experience of different industrial companies across the globe and across industries with Egamaster, let me highlight just a few. Companies like Borouge, the petrochemical sector of the UAE and Abu Dhabi, Coca-Cola, Total from France, WEG, a Brazilian multinational company having plants all over the world, but this one in India uses our tools, for instances. Alstom, which is a key player in such a growing industry all over the world, such as the railway sector, or Nestle, just to have also a prestigious name from the food and beverage industry. So I believe we feel a bit more familiar with our brand already, so we can move on to the main of the day, which are 1,000 volts insulated tools and what does that represent in terms of electrical safety, starting with the context. Let me show first a 2-minute video describing the risks of electrical shock and how preventing it must be a priority that we can't compromise.
Electricity is a phenomenal form of energy, and it's perfectly safe when used correctly. But when it comes into contact with conductive material, electricity travels at lightning speed. Water, metal, or even your body can be a conductor if you were to come into contact with a bare or damaged wire or unprotected equipment. Electricity will always be faster than you. That's why you need to avoid situations where you might come into contact with electricity. An electric shock can cause tickling or tingling, muscle spasms, serious burns, or even a heart attack. Why are there so many variations? Whenever you're in a dangerous situation involving electricity, 4 shock factors immediately come into play: voltage, resistance, path, and duration. Voltage can vary from just a few volts to more than 735,000. Still, even a low voltage current can cause serious harm. Your body's resistance to electricity can vary, depending on whether your skin is damp or dry. How the electricity flows through your body will have a major impact on the degree of electrical shock. There's a far bigger risk of internal injury when the current travels through your heart as opposed to just jumping from finger to finger. Contact can last for just a few milliseconds or more than a second, but even a few milliseconds is enough to injure you. The severity of the electric shock is determined by the combination of the various shock factors. It's impossible to predict exactly what the outcome will be before the accident, and it all happens in a flash. Electricity will always be faster than you. There's no such thing as a safe shock where electricity is concerned. But there's an easy way to prevent accidents. Avoid dangerous situations.
I can add now also a couple of videos that show the potential consequences of not having the right equipment, including hand tools, of course, or the right working procedures when dealing with electricity. I believe you are all familiar with this kind of incidents and how tragic they can be for people and assets alike, but it's never too much to review it. So here's some situations that speak for itself, including the dangers of arc flash. These are just 2 in hundreds of accidents that we could be showing today that are easy to find on YouTube. So while efficiency is important, let's say fundamental, and everyone these days wants to optimize their resources to the most, safety is really a priority that can't be compromised, can't be risked if you want to ensure safety of your manpower and your assets. These examples in the screen are just few in among many accidents that are still caused these days by electrical power. And once again, we could be talking about many others, but I would like to highlight the fact that in Spain alone, 5.8% of all mortal accidents at work result from contact with electricity. This is a lot. Even in a country where regulations and procedures are clear and where the safety culture did improve a lot in the last couple of decades. But as always, in everything related with safety, there's still a long way to go. Because any single accident is, any single casualty is one more that should have happened. It's one more that we could have avoided. And that is all over the world, particularly in countries where that safety culture is not yet so developed, let's say, not seen in some cases as a priority, unfortunately, and contrary to all common sense. And thus the awareness about the risks and the tragic consequences of these accidents is not yet widespread to the workforce. So that's a lot to improve. And I believe all of us here today can play a role on it. In our case, as a premium tool manufacturer, sharing info on the potentially catastrophic consequences associated with choosing the wrong tool or not ensuring on the other side that the tool selected is the right and the safest tool for the job is something fundamental for us. We believe it's critical that workers are 100% sure that the tools they are using are safe, certified against the applicable standard, and thus won't leave them harm when doing their job, and that they'll be able to go back home at the end of the shift safely. Giving just a brief story context to it, since the beginning of the 20th century that the economy started assuming a global scope, going global, thus the need of course, rational, universal, standardized system based on science, people started to feel it was a need, it was a must. So That was clear, for instance, during the World Fair of 1904 in St. Louis, the US. One of the attractions or exhibitions that was there in the World Fair related with electricity, the Palace of Electricity, as it was called, and you can see those old pictures on the right side of the screen. In that Palace of Electricity, there were different voltages, electrical distribution systems, frequencies, and that led to the need of different types of cables, connectors, everything related with electrical transmission. So that was probably the trigger to the creation of the International Electrotechnical Commission, the IEC that you will hear so much about today, founded in 1906. And you can see a picture as well of that initial report. And the IEC had precisely as initial targets the unification of units of measurement of all electrical variables, developing a system of clear and rational understanding to identify then every machine or electrical device. This commission started with only 16 members, mostly of them European, I believe about 13, and then Japan and the US, Canada, etc. And they had a considerable expansion in the decades that followed, publishing several fundamental standards expressing the notorious technological developments of the time in areas as transportation, telecommunications, electronics, etc., until we reached in 1960 the International System of Electric Units, which was one of the initial targets, as I mentioned earlier. Since then, the IEC became one of the most important international organizations for standardization and working together, of course, with the ISO, the International Organization for Standardization, the ITU, the International Telecommunications Union, and these organizations together have built what is considered today probably the most important and globally well accepted set of normalization standards in the world. So after this better understanding where all of this came from, what are 1000 volts insulated tools? Those are hand tools, steel hand tools, whatever, that were insulated, so you can use them on live parts or under voltage or close to live parts under voltage with the nominal voltage up to 1000 volts AC or 1000 volts DC. So we are not talking about tools that can be used under any kind of voltage, obviously. It has its well-defined limits. And in fact, the regulation requires voltage to be turned off, switched off whenever any work needs to be conducted. However, there are always risks associated, even if the power is switched off, reason why using 1000 volts insulated tools is actually mandatory. All these tools must comply with the IEC 6900 from the International Electrotechnical Commission. The IEC 6900 is the international standard, which I believe actually started initially to be the German DIN standard. It became later an European EN standard, and once the IEC decided to create and unify the standards for insulated tools to be the homologation of insulated tools done by different manufacturers, basically what they did was to transpose the EN 6900 to its own regulations. That's actually the reason why sometimes you may still see some literature referring to the EN 6900 or whatever, but all means the same. Is the international standard that regulates the manufacturing and testing of 1000 volts insulated tools. It is accepted almost in every country in the world. Of course, then different countries transpose that international legislation to their own local standards. Countries like United States, Canada, Brazil, or India commonly do that and have their own designations and standards. But for instance, in the case of the United States, the ASTM 1505 is basically and once again, a transposition of the international standard, the IEC 69900. So what are the main fields of application? All kinds of electrical installations or electrical MRO. power plants, stations, substations, again, very important, and the expanding industry of electrical vehicles, low voltage networks, high voltage. Now, not so much for the high voltage grid itself, since as we have seen, these tools can be used on the high voltages that can be achieved, but rather in the transformers that lower this voltage in telecommunications, electrical maintenance. Firefighters who often have to access buildings or places that have, for instance, been flooded, where electrical panels are exposed, or doing fires because electrical risk can always be a problem to them. Installation or repair of lighting, and in summary, any industry or any sector where electricity is used. So why should we use them if we already said that the regulations prevent technicians from working while the network is on, and that the system must be switched off before starting any activity? The idea was actually never to simply keep the system running while doing maintenance because you are having an insulated tool. You cannot have that risk, but rather use it as a safety measure, since even if the electricity is off, there's always a possibility of accidents, as I mentioned earlier. Some problem may arise during work. If someone, for instance, reconnects the power supply, the voltage suddenly returns, and you need to have that first mean of preventing the accident. Or due to residual voltage that may also exist and remain in the installation even while the system is off. So that's the concept I want to share. We want to prevent tragic accidents from happening, and thus all the means available are necessary. And as in every area related with operational safety, redundancies are a fundamental and a critical part of a safety culture, because even in the worst case scenario, you must be ready to avoid or prevent the risk. And if even after that there's still accident, and accident still occurs, companies also need to be ready to deal with it and minimizing its consequences. So how to identify 1000 volts tools and use them properly together with other safety precautions. First of all, we are dealing with safety related issues. So the manufacturer needs to be very well identified, the brand of origin, either on the insulation or metallic part. If something happens, you need to know who manufactured that tool. There must be some consequences and responsibilization, and then some kind of traceability as well. So the year of manufacturing, at least the two last digits are also mandatory. And together with that the symbology of the double triangle with the reference to 1000 volts immediately after needs to be engraved or marked in the insulating part of the tool, together with the respective standard. I already mentioned IEC 6900. So let me call your attention at this point, because you do see tools on the market that are called, I've seen them, electrician tools, electrical tools, even insulated tools with some kind of plastic cover. In some cases, even the colors are wrongly perceived by users, mostly as if it represented an IEC 6900 certified tool. But without this marking that you can see on the screen, there's absolutely no evidence on the effectiveness of that insulation, that these tools are safe. That these tools were prepared for the same as a 1000 volts insulated tool, that they comply with the required tests and regulations. So we all need to be careful with what is out there available, because we know already the consequences of a poor, or let's say a wrong decision that can be absolutely tragic. You can have a false sense of safety that doesn't exist. So obviously falsifications, fake engravements, that those things can occasionally still happen, unfortunately. But in principle, a tool that follows this kind of marketing symbology in this exact same way should give us some assurance that it has been designed, manufactured, and tested according to the IEC 6900 standards, meaning it should be safe to use as described in the previous slide. Or in other words, let's say, if it doesn't have this exact same type of marking and correctly done, we better be suspicious about that too. What else besides 1000-volt tools is important to consider when working in areas that may be under voltage? The tool is fundamental, but can't be used, shouldn't be used alone. As mentioned earlier, we should be having all the possible safety measures in place, all the equipment to prevent an accident caused by an electrical shock. For instances, if for some reason it's not the tool that touches the part that may be under tension, but a part of the worker's body, the arm, the elbow, whatever, because of an oversight, a loss of balance, etc. These things can occur. And so the tool won't be of any good, won't prevent the body from being the conductor that we don't want it to be. Thus, it's advisable that insulated floors are also used. Carpets, blankets, insulating blankets for the equipment, safety footwear, insulated gloves, of course, etc. So everything must be used, everything that may prevent the worker from conducting the electrical current from becoming the ground line. So again, you never know what may happen, and relying only in one safety mean, for instance, the gloves, and the belief that the gloves will isolate you or the worker from any risk, while in theory it's correct, it won't prevent accidents from happening if the conditions do change, when the unexpected happens. And we know in the most tragic as accidents, most of the time it was not because they were not prepared, it's because something unexpected happened. So the conditions change. So it's always better to be safe than sorry. And again, a fundamental part of a well-implemented safety culture in a company or institution, all these things, all potential values in consideration. So another important aspect, and that I believe we all know since childhood, is that it's common sense. Water and electricity just don't go well together. So it's not a good idea, and it must be avoided. And then that we shouldn't trust. We shouldn't touch directly any part that is likely to be under voltage, even if the system was already cut off. But we should always rechecked first that there is no voltage passing. Just use a tester before starting the job. Something else we need to consider, and that's actually the user's own responsibility, as in summer or whatever. They should be checking that every tool or equipment they are going to use, the same happens with the gloves or with the footwear, that everything they're about to use is actually in good conditions, that are still as safe as it's supposed to be. For instance, in the tools, for example, that the insulation is in good conditions, or if it has pores or cracks or fissures and embedded elements, anything that may be damaging that insulation that prevents the electrical shock, that should be a subject of concern. So in the case of our tools, not from every manufacturer, if the yellow layer is visible, because, and that's actually a great benefit, safety, and both safety and economic benefit to the user, to understand if the tool is safe and they can keep on working with it, or if it's better to replace, buy a new one, because you can no longer trust that the insulation is still in good condition. So seeing the yellow layer in the handle means it's a good idea to replace the tool. But let me explain at this point, perhaps, that there's two types of insulations, and because there's, I see commonly in users some mixed perceptions about this, particularly about the safety of the different methods. So there's two common methods of insulation that a manufacturer can use to turn a normal steel mechanical tool or industrial tool into an insulated tool. The first, like the one you see on the screen, basically what we do as a manufacturer is to dip that steel tool in a tank with liquid plastic, and every time you dip it, it creates additional layers of insulation until the necessary to withstand the tests and to protect the users of the tool. Then, of course, using an industrial oven, it requires heat treatment, so the insulating plastic cover gets attached or embedded in the metallic part and doesn't come off. The other option is to use an injection-made handle done in a machine with a mold, of course, and place it or inject it directly in the handle of the tool. That's, for example, a common method for items of very large rotation and demand, like pliers and screwdrivers. So You may wonder which one is the best or the better. In fact, both of them are completely safe, and they need to comply with and withstand the same different tests, destructive and non-destructive, of the IEC 16900 standard that we are going to see in the next topic of the webinar. Of course, each method has its advantages depending on the type of tool. Even on the volume of the tools, there are several decision-making criteria that leads a manufacturer to prefer one or the other, but both immersion and injection are valid and equally safe ways of insulating a tool. There's no one that has at safety from the safety point of view and angle, they are at the same level. An advantage that we could mention in case of the injection made handles, besides its superior resistance, because they are not easy to damage, they are not as easy to damage as an insulation made handle by immersion, reason why we need to have that, or we offer that double colored layer in our case, so you can see that the handle, the insulation has been affected. Is that also, apart from that superior resistance and the lifespan of the tool, is the fact that you can have better ergonomics with different levels of roughness to avoid slippage from the hands of the technician, and being more comfortable to the hand of the user. So that's something that unfortunately cannot be achieved with an immersion handle like the one on the screen, because the adherence is given by that plastic coverage layer alone. It has that, that's what you can do. It has a fundamental an advantage. Immersion is a very easy method of insulation, much less costly, so it makes the manufacturer much more flexible to insulate a specific tool that may have not been necessary, but suddenly you get that demand from the market, from a specific user, and you can insulate that tool with very small quantities. So the quantities are not that significant in the decision, and it's something that needs to be considered once you need to invest in molds for injection. I repeat again for the third time, from the safety standpoint, both methods are exactly the same. And you'll see once we talk about the regulatory field. But from ergonomic and durability perspective, injection handles are better, but not always possible. The thing is that as a manufacturer, we offer both solutions. So something I call once again your attention to, because not all manufacturers, or better say, only few of them do offer, is the double colored insulation that you see, and the great benefit it brings to you as an user of the tool, because it helps you to understand when is the right time to replace that tool before taking risks. So the tool may have suffered some kind of crack or pore in the insulation, but not yet be dangerous. It might yet be in the outside layer, the orange layer. So it's something you can't be really sure in case you don't have that double layer in the different colors. Moving on to, let's talk finally about the regulatory field established by the IEC 16900 and the certifications or additional third-party certifications to be considered in the case of insulating tools. The fact is that the standard or norm is very large, very detailed and specific for each type of tool, but in general, it basically requires each single tool or every single batch of that particular tool to be tested at 10,000 volts, meaning 10 times more than the standard it allows the tool to be used. So it's the standard says that the tool can be used up to 1,000 volts, but to certify it, it needs to be in conformity with a factor 10 times higher than that certification. The electrical test will be at 10,000 volts, and it needs to pass it for 3 seconds. So the manufacturer then needs to verify that no leakage or current passed through the insulation. So safety-wise, it is a very conservative standard. You can see on the screen some pictures of our own laboratory in Spain, the two on the left, where we performed, among among many other tests, these dielectrical 10,000 volts tests with different types of tools. You can see pictures with pliers and screwdrivers using water as a conductor. So what we do, we add an electrode on top of each tool and another one on the bottom layer where the water is. And then we add the electrical tension at 10,000 volts. And what is measured is if there was electricity passing through the insulation between the two electrodes. If that happens, the tool will be rejected since it's not complying with the dielectric test demanded by the standard. And that is done for each and every single tool before being available to the factory, before to the market, before leaving our factory, our facilities. These there are also tools that need to be tested in a different way, where we can't use water for it, like insulated torque wrenches, for example. And that's what you see on the picture on the right side. So where you see those gray spheres, basically we use the same method with two electrodes in those two handles, and we just dip the insulated wrench there, and we verify by using one electrode in a metallic part of the wrench in the square drive, for example, and the spheres to see if the electrical tension passes through the insulation. Again, in the standard might not be as demanded. I remember that some years ago in Brazil, the demand used to be, or the requirement used to be 5,000 volts instead of 10,000 volts. But internationally speaking, as per the international standard, the IEC 6900, the safety factor must be always 10 times more than what the tool is certified for. But in addition to this individual dielectric test for each single tool before releasing it to the market, which comes at the end of the procedure, each of the production batches it needs to withstand, or we need to perform a series of destructive tests on the tool by sampling a certain percentage of each batch. So we have both the statistical occurrence and also the physical occurrence, the physical testing, and then with the 3-second electrical test, that these tools are safe to be used and there won't be any specific problem with any of the tools or any of the batches. Of course, we can't perform the 5 additional tests in every tool because otherwise we will destroy the batch, potentially destroy the batch, and we'll be left with no tools to supply. So only some samples are actually necessary. And again, following very strictly what the standard defines, and then it is understood that the entire batch is fine and complying with the standard. That's the same we do even with in other types of other product families, other types of tools, following the very strict North American military standards. So that's the one we use for quality control in every type of tool. But in the case of insulated tools, it also has that specific regulations and percentages defined by the standard. And describing briefly these tests one by one, the first is that we need to perform is the adherence test, the adherence of the insulation. And first, the tool spends a week at 70 degrees Celsius in an oven. So it's something that could soften the tool, the insulation, the glue that could lose its properties, the glue that connects the insulation to the tool. So in its own, it's very challenging to the properties of the tool and the insulation. And then on top of it, after that, the weight of about 50 kilos, it varies, but in average 50 kilos, is applied to the handle, checking that not only the handle, the insulation didn't come off, but in fact, it cannot be moved at all. There can't be any single movement. So it's, to start with, is a very demanding test. But then we need to perform an impact test as well. And the tool must be impacted in all these 3 areas most likely to be hit or affected in case the tool falls. If it hits the ground and the material is fragile, if it breaks or gets cracked, that's in the insulation that the worker doesn't notice before he hit again, and so then getting an electrical shock. So therefore, these tests must be done to ensure that the handle is sufficiently resistant to impacts in those areas that are likely to be hit when falling. We simulate the hit, first of all, an impact in the handle, in the bottom part of the handle, and then a fall from 2 meters high. And we verify then if all these areas, including the safeguards that were mentioned in the previous slide, and I forgot to talk about it. Not every brand is having those safeguards, but that exists in the design of the tool, in the shape, to prevent the hands from sliding off or forwards and touching the metallic non-insulated part of the tool. As third, we'll have the flame retardant or heat resistant test to ensure that the handle and the insulation won't conduct a flame, won't start a fire. So to test, a flame is applied for 10 seconds to the handle, and then for 20 seconds we need to observe if the flame is not projected from the handle, if it doesn't reach more than 120 millimeters in height out of the handle. And of course, furthermore, we need to ensure that once the flame is removed, that flame immediately goes off in the handle as well. Anyway, if the flame does not exceed that height of 120 mm during 20 seconds, we can say that it has successfully passed the test. The fourth test involves creating a recess of 1 to 2 millimeters approximately on the handle, and then we need to apply 5,000 volts. Why we do so? Because of course, when the handle is new, it supports 10,000 volts. But of course, the handle is not new forever. It's only new once. So what happens if during normal use it suffers the normal wear and tear in the meantime, while the tools are in the toolbox, while being used, etc.? We still need to ensure that the insulation, even if it gets slightly damaged, that might not be visible or noticeable to the user, that it still has a certain degree of protection. Might not be exactly the same as in the beginning, but it still needs to ensure a minimum of 5,000 volts, even with that minor recess or impact, knowing that, again, these tools are certified to work under 1,000 volts. So even with slight or minor deterioration, they are still very, very safe. And finally, last but not least, the 10,000 volts test is also performed in that particular batch as part of the destructive testing. Of course, not the same dielectrical test of 3 seconds that will be done then before releasing it to the market in every single tool, but in this case for 3 minutes. So 10,000 volts applied for 3 minutes. And again, the same procedure to see if it withstands the 3-minute test and there is no current passing. So if the results in all these 3 tests of the batch are satisfactory, we'll consider that batch okay, and then we'll need to test every single tool, every individual tool for 3 seconds on the 10,000 volts electrical test to consider that that tool is compliant with the IEC 60900 international standard. You may have asked yourselves at this point, because VDE is quite famous, and you may have received requests, your customers or users may have asked VDE tools, and where does VDE fit in all of this? Is it something, in many cases there's a wrong perception that this is something different or a higher level of certification, safer, more demanding than the international standard. So VDE is actually a very well-known German institute they are dedicated to creating standards for insulating materials, cables, switches, everything that has to do with electrical power. But they also certify that an insulated tool that someone like Egamaster manufactured was done in accordance to the IEC 6900. So they run the test and confirm that that particular tool, that particular size they tested is compliant with the IEC 6900, allowing you to then use their own VDE symbol in the tools, engraved in the tools together with the international standards as additional assurance to the user. They have been doing this very successfully. So the VDE certification, which is not more than the third-party certification that other prestigious laboratories around the world could be doing, but the one mostly recognized in this product category on this type of safety tool is the VDE. So that's what they do. They became a reference in the market, confirming that a certain manufacturer complies with the IEC 6900 certification. So we did certify our tools through the VDE laboratory, such as our insulated tools, of course, this applies to insulated tools alone, our pliers, spanners, screwdrivers, ratchets and sockets, etc. So I believe we are about to run out of time, so let me go quickly through the last point before the Q&A. We are extremely late already. So what are the main 1000 volts insulated tools? I could be telling you about, for instance, our patented master cut pliers with 60% higher cutting capacity than others on the market. There's a special design, of course, and special features. The same happens with our Master Torque patented screwdriver with 30% higher tightening capacity than others on the market, again, because of the special design and features. And these are only two among more than 200 patents of our very highly innovative range. With innovation and added value being directly based on our conversations with users of the tools, with their identified needs. So that's usually the strategy we follow. We try to understand where we can benefit the users in terms of safety and efficiency in their job. But the main message is that the range is quite wide and comprehensive. The most complete, I believe, that any manufacturer in the world offers in terms of insulated tools. And it includes, for example, also our plastic tie cutter, which is a very interesting tool we developed some years ago for Volkswagen in order to safely cut the plastic ties without damaging cables, components, pipes, what you see on the pictures. Our insulated pipe ranges, and it is true that it's less and less common that electrical cables are kept inside threaded metal pipes. But when any kind of maintenance needs to be done in those pipes, and no one really knows in which condition the wires inside the pipe are, it's always good to have at hand an insulated pipe range. I'm sure it has been preventing a lot of accidents around the world. It is also worth mentioning the complete range of spanners, all types and sizes, including very small to very large, both metric and imperial. And the same applies to sockets from a quarter, 3x8, half-inch drive, metric and imperial, shallow and deep or long, hexagonal by hexagonal, etc. So in a single premium manufacturer, you do find the complete range, the most complete range that you may need for your electrical maintenance, fully in compliance with international standards, third-party certified with lifetime warranty. So we finally reached the end of the presentation. We just checked the time. And hopefully we still have a few minutes before we end the session for some questions. Let me remind you once again, last time, to follow us on LinkedIn. And now I need the support of my friend Borja to see which questions were placed during the webinar. Borja, can you please select a couple of questions?
Yes, David, thank you. Thank you for the technology you have provided us within this webinar. So yes, it was a bit longer than expected, but of course, well, we felt it necessary to explain everything that involves electrical safety. That we have watched today in this webinar, and I will have found it useful and helpful. So anyway, we can answer a couple of questions, David, of course. So let me check the chat. Okay, yes, we have one from George. Thank you, George. He asking if these tests are done once a new tool is manufactured only, or if you need to repeat it in every single batch.
Okay. I think it's a very good question, George, by the way, thank you. The standard is very clear in that respect. No matter if you produce the first batch, or let's say the batch number 500, you always need to follow those same procedures I described, the same tests, destructive, non-destructive, by sampling, and obviously the final 10,000 volts electrical test for 10 seconds. So it doesn't really make any difference if it's a new or not so new tool in the range. And if I understand correctly where your question wants to go, both of them are equally safe. So it's not that you do test once and then anything can happen in your manufacturing procedure and you don't really notice it. No, it will be equally safe being a new product or a product you've been manufacturing, in our case, for decades. I hope that answered your doubt, your question, Borja. I think we have time for maybe a couple of more.
Yes, of course. Yes. Here, Mr. Ahmed is asking if tools cannot be 100% insulated.
Okay, good question as well. Thank you, Ahmed. There are few tools that will have a complete, though a thinner insulation. We have them, but it's quite difficult to insulate the full metallic surface of a tool because it needs to be used. And we are doing heavy duty maintenance jobs, very demanding maintenance jobs. It's not a decoration object to be on the table. So there will be metallic parts or steel like blades that must be in contact with that potential live parts. And even if the tool is fully insulated, even in those blades, those will get damaged at some point. So I would say the key for the insulation is in the handles, where you need to hold with your own hands and prevent electrical shock, and not if the tool is 100% or entirely insulated. I don't feel it brings any additional safety benefits. Even because, as discussed earlier today, other safety means are more important and should also be used, not only the tool, but the gloves, the insulated shoes, the insulating floors. All of that is a must. So safety is achieved by using and combining all these presumably redundant methods, that all of them together and simultaneously, even if at some point people feel that you're already using one and you can just drop the others. Safety can only be achieved if you are combining all of them, all these redundant tests. And that's much more relevant than if the tool is entirely insulated or not. Borja, please, one more question.
Okay, yes, we are going to answer the last one. This one it's only really interesting. Alex is asking, for Alex, thank you, Alex, is asking what should they do if they need to use non-sparking tools for explosive environment, but electric risk are also present in their job.
Non-sparking tools, right? That's what you said. Okay.
Electric risk are also present in the job.
Okay, got it. Got it. Alex, right? So it is in fact a very interesting and great question, because it's a challenging scenario. It's a challenging application. So the good news, Alex, is that you are dealing with a specialist. We know very well the type of job and safety issues that you may need to deal with, depending on the industry. If you are in the oil and gas sector and you have explosive environments, but you need to do electrical maintenance, so you need the two types of protection, and we do offer solutions. I mentioned in the beginning that that's fundamental part of how we define ourselves. More than the tool manufacturer is a solution provider. So we do manufacture a range of non-sparking insulated tools with that same type of insulation and the same compliance with the international 6900 standards, conducting the exact same tests, but the metal alloys used in the tools below that insulation won't be steel, made of steel, special steel, or whatever you want to call it, but copper-based alloys because of the spark issue, specifically copper, beryllium, and aluminum bronze that will have even sparks will have lower energy and temperature than the minimum acceptable. So that's another area where we are experts and have been manufacturing this tool range, non-sparking tool range for decades. So with this non-sparking insulated range, we guarantee to the users the two types of protection against electrical shocks through the 1000 volts insulation and against igniting an explosive atmosphere by gas or by dust, zone 0, 1, 2, 20, 21, 22, having these insulated tools done in non-sparking alloys or non-sparking materials. So my explanation was a bit confusing, but I hope I answered your question. And considering that we are reaching 1 hour right now in 2 minutes, so I think I have no other option than simply thank you all for your participation in this webinar, your interest, the questions, and I believe there must be others in the chat box. And well, just rest assured that in Agamaster you have someone, a specialist, that will be here for anything else that you may need. just reach us by email or phone with your challenges, with your issues, with any type of support that you may need, and we'll be more than happy to answer. So hope to see you all again soon in other events of the EGA Group, and thank you. Take care and goodbye.